Hi there. This is the fourth in a series of videos about how to deal with uncertainties when doing an IB paper. Now in this video we're going to take a look at our graph we have here. We have our graph of, we have distance on the y-axis, time squared on the x-axis, title, all of which I haven't put, and we have put our error bars. These error bars correspond to 0.02, which is our uncertainty of our time squared. Now, of course, in your evaluation, you're going to talk about why that's your biggest uncertainty, probably because it's difficult to time how quickly stuff happens, but that's another story for another day. In this video, we're going to take a look at the min and max slopes for this graph. We're going to calculate them. We're going to talk about how those are important and so on. The first thing I do want to look at, though, is that my best fit line does go through all my error bars. That tells me that all my data does agree with each other. It does work out. Now I want to make two lines. I want to make a min and a max slope line. Now typically what I'll do is I would make one graph on my report where I have the equation and all that, and then I have a second graph dedicated to the min and max slopes. Now to find the min and max slopes, we got to sort of do a little thinking. So the maximum slope we're ever going to have is if we take the minimum uncertainty of this point and go to the maximum uncertainty of that point. That would actually be the maximum slope. Yes, that's what I meant. So this is the maximum slope, and the minimum slope would be the biggest one here to the smallest one here. So what I'm going to do is I'm going to go ahead and we'll have our x values and our y values. And I'll just merge these together. And what I want to do is, well, maybe I won't merge them together, but what I want to do is I want to go ahead and I want to make some two sets of points. One of them for the minimum slope, one for the max. So I'll make this min, and I'll make this max. This is going to help me keep things straight. Now, as we said before, the error bars are only on the time squared values, and so the distance values, our y values, will stay the same. So for the distance value, I'll put 0.1 here, and 0.7, 0.1, 0.7. I don't need to worry so much about dealing with what decimal place you're going to, because the data I'm putting here will not go on the actual report. This is just going to aid me in drawing the min and max slopes. And I could probably put them in the right places. There we go. That's what happens when we have a microphone in the way. Now for the x value. I'm going to go ahead and say the x value for that, the 0.1, the value is 0.02. Of course, if I subtract 0.02 for the minimum slope, remember the minimum slope is from here to here, I'll have an x value of 0 for that. For the 0.7, if I go out here, this is 0.15 plus 0.02, so that'd be a 0.17. For the maximum slope, I'll go from here to here, and so I'll have 0.02 plus 0.02, 0.04. And for this top point, I'll have 0.15 minus 0.02, that'd be 0.13. Now I can go ahead and make my graph. Let's just clear out this equation for now just to save some space. And I can go ahead and select some data. And it popped up on the other window. Now, you've heard about series. We typically don't worry about series too much. But in this case, I'm going to say this is my main data. I'm going to add another series. This is min slope. And I'll add a third series that is max slope. Whoops. And I hit enter and I get weird data, whatever. All right, for the minimum slope, we know our two x values. Two x values are right here. If I can select those, there we go. And for the minimum slope, our two y values are these two values right over here. Select those and hit there. For max slope, I'll do the same thing. Max slope, the x values are here. And the y values are here. I like making it very obvious on the graph. Just makes it easier for me. And now we see that we have two sets of points, the red and the green. Of course, I need to add trend lines to those. So I'll add a trend line to the green, add a trend line to the red. Of course, on both those trend lines, we can go ahead and add an equation. So it starts to get a little messy, but we can sort of see what's going on here. Display equation. And so now we have our minimum slope and our maximum slope. Now you may say, oh, Mr. Reynolds, why is that important? Well, let me explain why. These slopes are going to help us actually find the uncertainty of our slope. These min and max slopes will help us find the uncertainty and some other things we'll talk about in a second. So what I can do to find the uncertainty of slope, I know the uncertainty is equal to the maximum value minus the minimum value divided by 2. Well, in this case, I have a maximum value, it's the slope there, and I have a minimum value, it's the slope there. So what we'll do is we're going to go ahead, this is going to be a longer equation, but it'll help us figure things out. And I'll go ahead and label this uncertainty of slope. Now, I'm doing things in a fairly messy fashion just so you can see things on the screen, but in this case, I'll take the uncertainty of slope is going to be equal to, I need the maximum value, so the max slope is equals slope of, and I'll use my max numbers. There are the y's, there are the x's, minus my minimum slope. So again, I'll find the slope of my y's and my x's. Make sure all my parentheses are clear there. And then we'll go ahead and divide by 2. And this is the uncertainty of my slope. Now, the uncertainty of slope, when you're finally putting this in here, one digit is good. 2 digits in this case, I think would probably be appropriate. We'll just go ahead and say 0.16. So my slope is my slope is equal to, let's find the slope. So the slope is equal to the known y's. On the y-axis, I have my distance. On the x-axis, I have my time squared. So my slope was, we'll format that to have one decimal place. There we go. So it's 4.7 plus or minus 1.6. Now I've got to tell you, that's not a great uncertainty. As you can see from this graph, this is pretty way off. So in my evaluation in this lab, when you're writing about things you can improve, you can certainly say that, wow, the uncertainty of the slope is very high. Now in this case, it actually does make sense. These numbers were actually made so that the slope would be 1/2 times the acceleration of gravity. Distance equals initial velocity multiplied by time, which would be 0 in this case because we're dropping something, plus 1/2 a, which is 4.9, times t squared. So in this case, 4.9 is our expected slope, and that certainly does fall within the uncertainty. Another thing I could talk about is if I use my equation, again, the equation is s equals ut plus 1/2 at squared. In this case, let's say I dropped the ball. Well, I would expect this ut value to be 0. If I look at this as a y equals mx plus b, this is my y value, my distance. My m value is 1/2 a. My x value is t squared. And my y-intercept is ut. Now, in this situation, if I am dropping a ball, the initial velocity is 0, and I would expect the y-intercept to be 0. And as we see, if we look at the min and max slopes, certainly the area that the min and max slopes envelop includes 0. So I could say that that does help verify that the fact the initial velocity was 0. Of course, in your evaluation conclusion, you certainly do want to talk about the fact that this is not a good uncertainty, and I hope in your labs you don't have uncertainties that are almost 1/3 of the actual number. Hopefully this is going to help you understand how to deal with graphs in an IB document. Of course, all these graphs would be placed nicely in a Word document, and you walk through what you're doing. In an IB document, typically the analysis part is probably the biggest part. So don't be shy about explaining to IB what you want, what you're doing. The goal of this IA is for you to demonstrate that you understand how to take data, how to analyze data, how to make an experiment, how to conclude the experiment. Hopefully this helped you.